All right, let's head out to one of the most fascinating places in our solar system, Saturn's largest moon, Titan. For years, there's been this huge mystery brewing deep, deep beneath its frozen surface. But guess what? A brand new discovery has just completely flipped the script on what we thought we knew about its hidden ocean. And the implications for finding life out there, they are absolutely staggering.
You know, when you first look at Titan, it's weirdly familiar. I mean, it is the only other place in the entire solar system that has a thick atmosphere and stable liquid just sitting on its surface. You've got rivers, lakes, even seas. But hold on a second. This is definitely not Earth. See that liquid carving out those incredible canyons? That's not water. It's liquid methane.
And this is where things get, well, truly bizarre. Think of Titan as a kind of twisted mirror of Earth. Here, our bedrock is, rock, silicate rock. On Titan, their bedrock is water ice, frozen solid at a mind-numbing minus 179 degrees Celsius. We have a water cycle, right? They've got a methane cycle. It's this incredible, yet just brutally cold, alien world.
So the surface is fascinating, for sure. But the biggest secret Titan has, it's not on the surface at all. Nope, it's hidden deep, deep down, underneath all that ice.
That's right, you heard me. Using data from the incredible Cassini mission, scientists finally confirmed what they'd suspected for a long time. Titan has a global ocean of liquid water. Not on the surface, of course, but a huge hidden sea just sandwiched between layers of ice. Now, this discovery was absolutely monumental, but it also created a brand new, very confusing puzzle.
Okay, so once the scientists knew this ocean was really there, the next obvious question was, what's it made of? And the very first clue they got, beamed all the way back from the depths of space, well, let's just say it was puzzling. Really puzzling.
To get what's going on, we have to talk about something called a love number. And yeah, I know, it sounds a little romantic, but it's pure physics, I promise. Basically, it's just a measure of how squishy a moon or a planet is. See, as Titan goes around Saturn, Saturn's massive gravity is constantly pulling and stretching it. The love number, specifically K2, tells us how much it deforms. It's kind of like this. A billiard ball, it barely squishes at all, so it would have a really low love number. But a water balloon, super squishy. It would have a really high love number. Simple as that.
And this is where the problem really pops up. Before Cassini ever got there, all the models predicted a love number of less than 0.4 for Titan. But when the first data came back from the spacecraft, the value was closer to 0.6. That is way higher. What that suggested was that Titan was incredibly squishy. And for it to be that squishy, its hidden ocean had to be extremely dense. We're talking about a thick, super salty brine, almost like the Dead Sea. And, that is not exactly a great place to start looking for life.
So the whole scientific community was basically scratching their heads. The data proved the ocean existed, no doubt about that. But the numbers, they just didn't make any sense with what they were expecting. Like the original researchers said, the interpretation was just unclear. Something was definitely off.
And this is where we get to the big breakthrough. A new team of scientists decided, you know what, let's go back to the very beginning. They took the original raw data from all 10 of Cassini's flybys of Titan and decided to reprocess the whole thing from scratch, using new tools and, really, a fresh set of eyes.
They started by asking a really simple but kind of bold question. What if the original calculation was just wrong? What if the super complex math they used to model Saturn's pull on Titan had some kind of hidden flaw?
And yep, that's exactly what they found. Now, the research paper itself is pretty dense, but the main idea is this. The first analysis kind of treated Saturn's gravity like a constant, steady squeeze. But this new analysis was able to capture all the subtle, dynamic changes in that pull as Titan moved through its orbit. It seems like a small error, right? But it compounded, and it led to a huge overestimation of how squishy Titan actually was.
So, after they corrected for that error and reran all the numbers, they landed on a new, much more accurate love number. And believe me, it is a total game changer. The new K2 value for Titan is 0.375. That's way lower, and it lines up perfectly with what the original models predicted all along.
And take a look at this heat map. This is straight from the new study. It shows us exactly why that new number is so important. What you're seeing here are the results of thousands of simulations. The vertical axis is the love number, and the horizontal one is the ocean's density. See that bright spot? That's where all the models agree.
And it lines up perfectly with our new value of 0.375, pointing directly to an ocean that's much closer in density to liquid water, and not a thick, salty sludge.
So, what's the big deal? Why is a less dense, less squishy Titan so much more exciting? Well, because it completely changes the recipe for what could be going on inside that hidden ocean.
A lower density means the ocean is much more likely to be mostly liquid water, maybe with a bit of ammonia mixed in, which would act like an antifreeze in that cold environment. This is a way more habitable environment than the super salty sludge the old incorrect number pointed to. But wait, the good news doesn't even stop there.
This new model kicks off this incredible chain reaction of possibilities. So step 1, you have a lower density ocean. That probably means the ice shell above it is thinner. Step 3, this makes it way more likely that the liquid water ocean is actually touching the rocky core at the very bottom. And if you have water touching rock, what do you get? You get chemistry. Minerals and other good stuff can leach out of the rock and into the water, providing the exact kind of nutrients and energy sources that could, potentially, support life. And that right there is the key takeaway, straight from the researchers themselves. This new finding makes Titan's ocean a much more promising place for life. It means it probably isn't just some boring, static pool of water. It could be a dynamic chemical reactor, a place where water, rock, and all those complex organic molecules we know are on Titan's surface could all mix together. It's the perfect setup.
And this is why this is all so important for us, back here on Earth. Titan, with its thick nitrogen atmosphere and all that complex organic chemistry, was already considered one of our best models for what Earth was like before life began. But now that we think there's a potentially habitable liquid ocean in contact with a rocky core, it just became an even more incredible natural laboratory for understanding how life might have gotten started in the first place.
Of course, in science, solving one big mystery almost always just opens up a dozen new questions, right? So this discovery isn't the end of the story at all. It's really the start of a brand new, thrilling chapter in our exploration of Titan.
Now that we have a much clearer picture of what Titan's insides look like, we can start asking way more specific questions. Like, what kind of minerals are actually dissolved in that water? Could there be hydrothermal vents down on the seafloor just like we have on Earth? And how does this massive ocean interact with the ice shell above it? The list goes on.
Which, of course, leaves us with the ultimate question. The evidence is now pointing to all the key ingredients for life as we know it being in one place. You've got liquid water, you've got an energy source from a rocky core, and you've got complex organic molecules. So, could something actually be alive in that dark, hidden ocean 100 kilometers beneath the frozen surface of Titan? We don't have the answer yet, but thanks to this incredible breakthrough, for the first time, it feels like a very, very real question to be asking.